So we have section 5 dividing polynomials. We're going to be using this division to find any factors of a given polynomial. And this is helpful when we have polynomials that are bigger than quadratics, that have higher degrees than quadratics. So we started this lesson yesterday by reminding ourselves about long division just with numbers. And then we had our practice problem. With long division, which was that one. And the work is there if you need to go back and check it. But right now we're going to move on. We've just done 4 practice problems, so we're going to skip this long division problem. I'll put some work in for it later on, so you have it there as an example. All right, so now let's take a look at this one before we move to synthetic division. It says checking factors. It wants to know if x squared plus 1 is a factor of this polynomial. Well, if it is a factor, what should the remainder be?
0.
The remainder should be 0. All right, and something else interesting happens here. Check the degrees. This goes from x squared to x to the 0. So it's skipping x to the first, correct? So we're going to do this one with long division, so copy this down. We will be doing 3x to the 4th minus 4. Should you use the 6 10s or not? That's better. Look at the 6 10s.
Check out.
All right, start from the right. Okay. Cubed plus 12 x to the 4th. The smaller pen, because I'm thrown off? I'm getting there. I know. Alright, I'll change it. I'm alright. 4x cubed plus 12x squared plus 5. And we're going to divide that by x squared plus 1. Now here's one where it skips a degree. So you'll need to put in a placeholder. So write yourself a little note. Placeholder is necessary. For x to the first. So we're going to put in a 0x for x to the first. So we will have x squared plus 0x plus 1. Okay? Yes, so we have x squared plus 1. It skips the x to the first power. So we're going to put in what's called a placeholder with a coefficient of 0. So we're not really changing the value of the expression because we have 0 times x. Okay? All right, so how many terms and what we are dividing by? 3. So we're going to move in 3. 1, 2, 3. Our answer will start here. All right, so this time we're going to have to distribute through 3 terms. All right, we ask ourselves the question, x squared times what equals 3x to the 4th? 3x squared. Notice we're above the x squared column, so that makes sense. We have 3x squared. Now what do I do with that? Yep. 3x to the 4th. Then what? Yep, and we're going to write it as 0x cubed, so that it's still a like term, because we are multiplying x squared times x, it's just the coefficient will be 0. And then what? I think positive, right? Positive 3x squared. And we are going to subtract. When we do this, our 3x to the 4th are going away. We have negative 4x cubed minus 0. So what is that? Negative 4x cubed. And we have 12x squared minus 3x squared plus 9x squared. Now what do I do? Bring down to 5, so I get 3 terms. Okay? And we ask ourselves the question again. X squared times what equals negative 4x cubed. Negative 4x. Oh, I did skip one. Notice we skipped here. We're going to change this up a little bit. We need a placeholder here as well. It's going from 12x squared to 5 with no x. So we'll put a 0x here, and then our plus 5. We're going to alter that a little bit. So what we are bringing down is 0x. So your answer on the top is still right. Yes. But we needed another column to put it above. And the reason I knew it was wrong is because it was x and it was in the one column, so it did not make sense. So what do we put in? Negative 4x. Distribute it through. And we'll still get 0, and we'll write that as x squared. And we have negative 4x times 1, giving us minus 4x. All right. Now we will do our subtraction. First one's gone. 9x squared minus 0x squared is 9x squared. And 0 minus negative 4x.
Negative 4x.
That's what?
4x.
Positive 4x?
Oh, yeah, right.
Yes? Okay. And what do? Bring down the 5. And it is plus 5. All right, last time, x squared times what equals 9x squared? And that makes sense. We're in the one column, so that's plus 9. And we distribute it through. 9 times 1 is 9. 9 times 0x is 0x. And 9 times x squared is 9x squared. Correct? 4x minus 0x gives us 4x. And 5 minus 9 gives us minus 4. Do I bring down a 0? Nope. Okay. So my remainder is 4x minus 4 over x squared plus 1. So is x squared plus 1 a factor? No, because the remainder is not 0. Okay, if it were a factor, our remainder would have come out to be 0. All right, questions on that one? Okay? Okay. All right. Now synthetic division. Okay, so a couple of things we have to note about synthetic division. We only use synthetic division when we're dividing by a linear factor. So that would be, so when dividing by a linear factor, such as x minus 4 or x plus 5. We cannot do it when we have x squared plus 2x plus 3. We cannot do it when it's not linear. Okay? And a couple of things to note about synthetic division. You always divide by the 0, not the factor. So if they're asking us to divide by x plus 5, I would not be dividing by x plus 5. When I set it up, I will be dividing by, what's the 0 for that? Negative 5. Okay, so you always have to divide by the 0. And then finally, the operations are always multiply and add. I'll get there. I haven't written it yet. The operations for the process are always multiply and add. Always, it's synthetic division. Okay? Given that, let's look at the one that they've given us. We have x cubed minus 14x squared plus 51x minus 54 divided by x plus 2. What is the quotient and the remainder? So the setup is slightly different when we do this. We need more room. All right, so the way we set it up, again, you have to look for any missing degrees in the polynomial. 3, 2, 1, 0. Be clear to me that we are not skipping any, correct? And the one we're dividing by is linear. So we're all set. The way you set up synthetic division is you only write the coefficient. All right? So what is the coefficient of x cubed? 1. Then
14.
negative 14. Then 51. Then negative 54. And I set it up slightly different than they do in the book. If you prefer their way, you can take a look at that. And then we are dividing by the 0. So the factor is x plus 2, so the 0 is negative 2. Okay, so that's the setup for synthetic division. The first thing that we do is you always just pull down the first coefficient, 1. All right, and now we're going to do the multiply and add, multiply and add. So I am going to multiply 1 times negative 2, and I will get what? 1 times negative 2 is negative 2, that goes here. Negative 2 goes right there. And now we add. Negative 14 plus negative 2 is?
Negative 16.
Thank you, negative 16. Okay, good. Second time through, we're going to multiply the negative 16 times the negative 2, and we're going to get what? Positive 32? Oh, and I wrote it. Positive 32. Now add, and what do we get? 8.
Do you want your official summer under return to
Yes.
their return?
Yeah. Thank you. That would be great. Thanks. All right. What do we get here? 83. Good. Third time through. Now we're going to multiply the 83 times the negative 2, and we get negative 168. Yeah. That looks right. Add, and we get negative what? 220? All right. So, once you get here, you're done. This last number here is always your remainder. And the meaning of these numbers and the coefficient of our answer, and our answer will always start 1 degree less than the degree of what we're dividing. All right, because we're doing x cubed divided by x, that means this has to be x squared. So our answer is 1x squared minus 16x plus, careful, 83, with a remainder of negative 220. Easy enough. And that's it.
That's quite a bit.
The only downfall of synthetic division is that it really only works for linear dividers. Okay?
Yeah.
All right, questions on the process? Okay, let's do another one. Well, we're not done. All right. So, let's find one from the homework. Okay. So let's do x cubed plus 3x squared minus x minus 3, and let's divide it by x minus 1. Okay? Check your degrees. Does it skip any? Nope. So our coefficients get written down first. What are they?
1, 3, negative 1.
We set up our little box. And what goes out here? Positive 1. Factor is x minus 1. The 0 is when we take x minus 1 equals 0 and solve, is x equals 1. All right, bring down your first coefficient, and now we multiply and add. Multiply, we get what?
1.
1, we add and get
4.
multiply,
4.
add,
3.
3, multiply,
3.
add, 0. Remainder is 0. This one is a factor. So if you're asked to determine if it is a factor of the polynomial, then you're going to set up your synthetic division and look for a remainder of 0. And my answer is what?
3.
So if I multiply this times x minus 1, I should get my original polynomial. Okay? Easy enough. Now, one last thing we have to cover. Using synthetic division, there is something called the remainder theorem.
Good looking apple are there.
Thank you very much. All right, so let's say we have p of x, and that is x cubed plus 4x squared minus 8x minus 6. And we're given that a equals negative 2. What we want to find is P of A. So in this case, we're looking for P of negative 2. So before today, how would you do P of negative 2? What would you do? Plug in negative 2 for every x and add it all up. All right, well, synthetic division gives you another way to do that. You set up your synthetic division and you divide it by this A value, negative 2. The remainder that you get at the end is what P of negative 2 is equal to. Okay, so that's kind of neat. So let's do it. We've got 1, 4, negative 8, and negative 6. 3, 2, 1, 0, it does not skip. And we are going to divide by negative 2. Now this time you do exactly the value that they give you. You don't change the sign. Set up your synthetic division, bring down the 1, multiply, add, multiply, add, multiply, and the top is 24, and we get 18. So that tells us that P of negative 2 equals 8. I don't know if it's any quicker than plugging it in, but I think it is less error prone. When people plug in and have to raise to a power, especially in negative, they make little errors in adding and subtracting. So if I plug in -2 in here, I would get 18, or you can do it with the remainder theorem and synthetic solution. Okay? All right. Let's take a look at what your homework is.
Oh boy.
Not that. All right. We're on side 4. Okay. So, we're doing dividing polynomial stage 2, and we're going to focus on 31 through 41 odd. That's all you have. Okay, 308 and 309, write that down, please. 31 through 41 odd. Now, notice, on the 14th, which is Thursday, that's a quiz. But what we will have first, so you'll come in, and we will have a review group activity first. You'll get into groups, and you have basically a practice quiz that you're going to work together on in groups. And then for the second half of the class, you're going to take the quiz. Okay? We'll review the homework first, and then head to the review activity. All right? So, right now, you are working on 31 through 41 odd. I want everyone staying in the seats they're in. I don't want you roaming. And we have about 15 minutes, so these go very quickly. So, get 3 or 4 done.
Can you pull the
And I'll go book up.